Welcome back, everyone, and today is going to be a special lesson. I know I promised I was going to do raycast for the next video, but last Friday Chrome 61 was released, and with it came a feature I've been waiting a very long time for: JavaScript modules. I've been waiting for this feature for a while. I didn't want to play with it when it was in beta and you had to turn it on with the flag, but as of last Friday, Google let it loose. Now it's officially the second browser to support JavaScript modules. First one was Safari. So I stopped everything I was doing, went quick primer to how it's implemented through Chrome, and spent a couple of days refactoring Fungi. All the work that we did, not all of it, but the majority of all the work we did in the last 9 months in this series, building up the framework, I redid the whole thing as modules. It makes it so much easier to manage the code, because I don't know if you guys have noticed, but fungi.core.js has been getting very unmanageable. It has too much content in one file. I've been waiting for this feature for a long while, and now that it's here, definitely time to really dive in. Granted, it's not production ready because, again, Chrome is the only one that supports it, and Safari. Firefox is coming soon, and eventually IE and Edge, whatever Microsoft wants to call their browser, will eventually catch up. So this video is going to be about me showing you the how modules work, how can you use them, and then we'll kind of quickly go through what Fungi looks like now as a modular framework. One other great feature, WebUSB. I don't know if it's going to be much related to this YouTube series, but that's something I really want to play with now that I'm done playing with modules. So moving forward, Fungi and this YouTube channel is going to do everything in modules. It's just a better way of managing the code for the most part. Just make sure that you have version 61 up on Chrome, because you need this browser to run. The only other problem with modules, it's the one that I'm not very happy with Chrome, is that you can't run this off the hard drive. You need to run this off some kind of web server. So I did update the web server that I built with Go. It's a small little script. I had to update the script because the default functionality that Go has for web servers, it has a MIME type of text for JavaScript. So I had to modify the script I had to change the MIME type to for JavaScript files to be like a JavaScript MIME type. That was like the only really big issues of using modules, is that you need a web server that supports JavaScript MIME types, which most web servers do, unless you're writing your own, kind of like if you're doing with Node.js or Go, which I use Go to build a mini web server. So if you go into the shares folder, let's see, not this one. So yeah, if you go to shares, Go web server, it's right there. Don't really need to see the code. It's you can see it if you really care about. But for this lesson and moving forward, all you really need is the exe. If you don't want to run the exe, just download Go and the JSON file. And if you have Go installed, just go run or go build, and you make your own exe. All right. So that's the only things we need to use modules. And since we're also doing downloading, so we need a web server now, because a lot of these things are not allowed when you're because you get this cross domain things and hard drive protection. Like, there's a lot of security in Chrome to make sure you can't run a lot of this code natively, that you have to run on the web, and you need a web server. So that is the only issues that we need to deal with. So yeah, let's dive into modules. Like I said, it's one of my new features. Let's see. So what are modules? You might be asking. Modules are it's basically packaging code. You can package a bunch of functions, a bunch of classes, a whole lot of code or very little code into one file. And one of the main reasons why I love this option of modules is the import function. The import function allows you to, it just includes, it automatically downloads the JS file and includes it, and it dumps it in the script. And quick overview, you can go into a JavaScript file and import. So normally you couldn't do that. You can't have a JavaScript file and say download more JavaScript. It doesn't really work that way natively, vanilla JavaScript. So module support add this functionality where you can just, any JavaScript file can load in more JavaScript files dynamically. Now, this functionality has been around for a while, but you needed third-party JavaScript libraries to do it. You had, I think, Require. I think it's called Require.js, and there's one called Common.js, and I think there's probably a few others. The only problem is using third-party libraries and using their version of it, and it's just a lot of overhead. And but it looks like modules was kind of modeled after Common.js, so it's similar, but the syntax is a little bit different in how it works. So even if you're using Common.js, you still have to do code changes to really bring it to the standard module specifications that exist in Chrome. That's kind of one of the reasons why I don't like to use third-party libraries for this functionality. So if the functionality is coming, a year from now, the spec can change, and that's always been an issue. Like, specs can change. So if you jump too early, things can change, and then now you're kind of stuck with this third-party tool that's now obsolete, and your entire site runs off of it. So I try to avoid doing it. That's why I haven't done modules. But now that it's natively supported, now you guys can start using it. And then when Firefox has it, screw IE and Edge. Once Firefox has it, I think people should start using it more for production. So, like I said, this is one of the most important pieces to me, because once you can import code, you can break apart your code base. You can break them out basically just like Java. And as you can see right here in the corner, you see I already have Fungi broken out. Before, it was like a collection of JS files in one folder. Now I can break them out into separate folders. In each piece, you remember renderable, transform, that all has to be part of core. So is maths. So every single piece, Vector3 is its own module file that you can include anywhere you want. So this way, it makes it so much easier to manage the code base. So now that you can break everything down. So the whole, like I said, this thing makes it easier. It's like kind of JavaScript, not JavaScript, like Java, where you can create folders and add Java files to it. And you start building this namespace structure of code that you can share. And this is what module support brings to JavaScript. It gives you that modularity. Now, there's some issues here and there. We'll walk through it. There's some issues I found when I was playing around with it, some gotchas. And so we'll get to that. So let's look at, so what's happening here is I'm telling it import, right? And I'm telling it what file. Now, you might not be used to seeing this single dot slash means current folder. You cannot do this. Module support requires that if you want to do the current folder, you got to do that. If you want to do a subfolder that's currently there, you would say basically, fungi / whatever. If you want to go backwards, up a level, double dot. But if you want to do the current file, the current folder that this HTML page lives on, you got to put that /. That's a requirement. So basically what this thing is import mod A from mod A. Basically it says download this JavaScript file and import all the exports, you will see that in a second, into mod A. So this becomes an alias. Now I don't have to call this mod A. I can call this mod A XXX. The beauty of this is that you can rename the module whatever you want it. You're not stuck using the actual name that's originally created for the module. And really, the module doesn't have a name. You have to give it a name, in all honesty. That's how it really works. I like the beauty of it because let's say if you have multiple libraries that you're loading in, and one of them has a vec3, and you want to use the fungi as vec3, now you're kind of screwed normally. That's why namespaces exist, so this way you can group code together. But for module support, you just give it a new name. Just say vec3 is now called vec3x. You know, it all works because it still knows it's that type. So this is just the name you make up, any name you want to call it, and that's just the name of the file. So that and it imports it, and then everything inside that module goes into there, and you can access it. And so let's look at some code, and we'll see what this looks like. So if I refresh the page, you'll see that loading mod A. You'll see that in a second, and this part right here. This log is this log right here. So what you notice is that the module that I'm bringing in, all it is just a single function. It's not a class. It's not a collection of anything. It's just a function. And then you see unchanged. That's me calling the module, mod A, because the module that I'm importing is really just a function. So now if we go to mod A, and here you see loading module A. So this way, I just wanted you to show it. And I've got some things in here kind of like a constant. And I have a variable, and I'm using the let command instead of the var. And you can use either or, it doesn't matter. In this instance, it doesn't matter. And you have some functions, and these functions kind of control this test variable. And I have a class, and I have 3 different ways of exporting. Now we have something called the default export. In the default export, you can only have one default export. And that is the export when you do an import, like this. So if I do an import variable name from this will load up all the defaults and put it into here. Or actually, it will load up the default. So it's only one default that I can load in. This default can be anything. It could be a function. I can say test can be my default. So if I do an import, all it is just a string of unchanged. I can make it a constant. I can make it a class. So when I'm on an HTML page, it's really this class file that mod A is. It's just a new name for class. So that's what default does. It's just it's basically, if you want to think about it, it's like a return. So if you look at this entire file as a single function, this export default is basically return this and whatever this you want it to be. I got a loud keyboard. And this is pretty much the same thing. And actually not really. You're exporting a variable, but it's a named variable. These two are similar. These are called named exports. This way, these named exports, if you want to import them into a page, you have to import them by name. So you have to know the names you want to import. So let's see. I keep going back to that page. So we're going to comment out this import, and we're going to get this import. Let's play with this one. Import star as mod A from mod A. What the star does is that it says grab every export in your module and make it part of this this variable. And when you do that, it actually makes a structure or an object that has a reference of every single export. So this won't work. This would be an error because the export is no longer a function. So when we refresh, this is what what it imports. It imports a module, and it has the class, the default, and the default is whatever default is, which is the out test. It has the log function and the set. So it has everything. Every single export gets dumped into the variable name that you picked. And like I said, with the named imports, you have to put in brackets. So let me comment this out. Do I still have other? I don't think I have other anymore. No, I got rid of other. So that's a typo. So it's just log. And log is this one. It's like a little mini function delegate. I forgot what these are called in JavaScript. I'm used to doing a lot of C#, so to me this is a delegate. So I forgot what these are in JavaScript, but they basically like functions. So this, you can just do it this way. And all you import is the log. And then you can do this, log. Refresh. Well, because it's not defined because I don't have it anymore. So refresh. There you go. Undefined, which I don't know why it's undefined. It's probably the worst test to try out. Maybe do constant. I don't know. Log O. Why does it? I don't know. This was working before. You know what a simple solution is? Function. I guarantee this probably would work. I've been playing around with this a lot to try and figure out some fun ways to show you guys, but I'm sure that will work. Refresh. Still not defined. God, I feel damn, that sucks. Shit. I know the out test works. No? Let me do this. Out test. I'm going to get this working right for you guys. Out test. And I say out test. Refresh. There we go. Unchanged. There we go. So yeah, I don't know. This was work. It does output, but for some reason I can't run it when I had that delegate looking thing. I don't use those that often in JavaScript, so I probably shouldn't be using something I don't use that often. I should really read in more into it. I was doing it before and it was working fine, but for some reason it doesn't work now. Even this way doesn't work. I wonder if I do it this way. Because I think I use the let command. That's probably why. No? Alright, whatever. No big deal. It exports regardless, even though it's not what I wanted. So, keep going back. Oh my god, I need to go back over here. So this is what a named export is. So as long as it's in this bracket with naming, you can bring it in. So if I wanted to bring in class, I just add it to the list, and I have access to class. So if I do that, refresh, now I have access to class, and class is there. Now, if I take class out, now I get the error because it's not defined. It doesn't exist. And that's the beauty of modules. You only import what you want. So you can, even though you do download that whole JavaScript file, you only import the references you need. So you're not filling up your module with a bunch of references or variables. So you only bring in what you want. And you can do two ways. You can do mod A. So I can actually import the default and a name, one of the named exports. So this way I still have out export, and I can still do my log. There you go. So I get both. I can do named and default at the same time. All right. So now let's look at some other examples. So now we're going to import two modules, right? So we refresh. Out test is undefined because I'm not using it anymore. There you go. So you got mod A and mod B. They're loading up. Perfect. Oh, you know what? Actually, I want to keep this one because then I want to test. I can probably do it this way, right? I call. So we do a refresh. Now you'll see. Let's see this mod B rules. That shouldn't be saying that. It should be saying something else. So if I don't import mod B and refresh, what I get back is unchanged. It's this variable right here. I'm outputting the test variable, which says unchanged. But once I load in, sorry, I keep flicking the wrong way. Once I load in the second module, that variable changes. Now it says mod B rules. Like, what the hell is going on? Now, what's going on is that when you load in a module, so like right here, I'm loading in module A. Now I'm loading in module B. Module A gets downloaded and it kind of gets stored globally as a reference kind of object, basically, in a way. And whenever you load up like another JavaScript and another module, and that module wants to import something you already have, it brings in that global one that's already been downloaded and brings in the reference to it. And the thing is that the state of that module is shareable with all the modules you download and you load up onto your web page. So what I'm doing is I load up mod a.js as mod, and I call one of its function set test, and I set it to mod rules. So if we go to mod a, here's set test, and that's what it does. It actually changes that variable to mod rules. So just by loading it mod b and then saying, hey, I need mod a, that's what happens. I get the reference. Now, here's the beautiful thing. If let me go back to the browser. Refresh. Now you see it's loading module A and then module B. That's perfect. That's the right order, right? That's the order that we're loading in them in. A and then B. Now what happens if I decide to move this up here? Ideally it would be B and then A, right? That's perfect sense. Refresh. It's still A and B, even though B comes first. And I can prove that B comes first if I go to network. If I go to network, B is the first file that's downloaded, then A. So why is A loading before B, right? So watch what happens when I undo that. See, it says B and then A, refresh. Now it's A and B. But when it comes to the output, it always stays the same. So the thing is that when B loads up, the first line of the code is to import A. So this load actually pauses, goes and downloads A, and then continues processing this page, this file, to produce this module. And then when this HTML page comes to, like, if I had it back up here, so it downloads this, it downloads B, and B says I need A as well, so it downloads A. And then when it's all done, you come back, the controls back onto the script and say I need A. Well, A has already been downloaded, so here's the reference to A. But that reference of A has been modified by B. So like I said, it's no matter which order you come in, it's always going to download it somehow or grab its reference and then modify it. So that's kind of like the beauty of it. So you can keep the scope of everything. And speaking of scopes, this whole page or this whole file, you can kind of consider its own web page. It has its own scope. And like I remember when in the previous, I was kind of showing you, or like once I take something out of here, I got it undefined because it doesn't exist anymore because I don't have a reference to that object. If you don't import anything from a module, you can't have access to anything. So if anything that's in here that does not have an export, there's no way to have access to it. So if I really wanted to, I can always have function private, right? Some kind of function called private. And if I never put an export on it, there'll be no way for the page or any other module to get access to this function. It creates a private scope in modules. If I want this to become publicly available, make it a public function, I need to add an export to it. So that's another thing that modules does. It creates a private scope, which is really good. Like if you're coming from Java, JavaScript, not Java, Java, C#, C++, you can declare something as public and private. And just by not saying there's an export, automatically makes it private. Same thing means with variables. Another beautiful thing about modules and scope is that this entire thing is a single scope. So you know how you have this class file and you have this global constant. Since class and test exists within this one damn it, I was saying it over and over again. Now I can't even say that word anymore. That scope. Since they share the same scope, you can do things like test equals this. Because test exists on the global module scope. Test doesn't exist on the page global or the window global. It only exists globally in this module alone. So you can then do some fun tricks by doing this. Like you can really convert. You can write a bunch of functions and that can use a global variable in a certain way. I'll show you that with Fungi a little bit. So that's another cool thing about this, is because you can write your modules without as a class without being a class, and you can get away with some really good things like like it's really you can get very creative with scoping when you have modules. So there you go. So modules can load up. They're shareable. Once they're downloaded, their state is shareable. You can change the state, and in any module that's loaded that imports it can access that state. Now, the one little tricky thing about modules, there's one little issue that I discovered just today, and I really want to mention this because I didn't realize it until today when I was playing around. So I'm going to load in module C, all right? What the hell? I'm on light 4. What did I screw up on? Man, I had this stuff working really well. Now I'm screwing up. Oh, you know what? I added some stuff somewhere. See, that's when I start modifying code, and then things start acting up. I don't know. So all right. So I'm going to import model C. Now remember when I said that when you load up a module, it becomes part of like some type of global cache of some kind that any other module or the page itself doesn't import. It grabs that object from memory and gives you a reference, and it gives you the reference to whatever exports that you wanted for your own module. Now, here's a problem. Module B is being downloaded twice. And if I go here, that's exactly what's going on. It's actually being downloaded twice. But I just said if you download it once, it stays in some kind of global cache that you can kind of just go and grab it whenever you need it. Right? So that's something's a little fishy here. All right? So if I come in here, I'm importing it. It's a mod B. It's perfectly fine. you might be like, what the hell? And trust me, today when I was doing this, I was like, what the hell's going on? Why is it not? Why is that? What? Because I was using a global scope, and it kept saying it was undefined. I'm like, but I'm loading it in, and I'm calling the initialization function. But then when I started doing comments saying to see when modules load up, I'm like, wait a minute, this module's loading up twice. It shouldn't be possible to load up twice. And that's when I kind of discovered not necessarily a bug, but something you have to be very wary of. When I'm here, I'm loading up mod B with a capital M, right? And over here, I'm loading mod B with the lowercase m. In Windows, the file system is not case sensitive at all. If you're not on Windows, everything is case sensitive. Websites are case sensitive unless it's on a Windows server. But if you're on a Linux server, Mac server, Unix server, it doesn't matter. If it's not Windows, it's case sensitive. Web addresses are case sensitive. Programming languages, everything is case sensitive. Windows is just weird that they actually let you get away with that. It's case insensitive when it comes to file systems and whatnot. So the browser, as an application that does not support case insensitivity, sees mod B and this mod B as two different files. It considers them different, even though they are technically the same file, and it is the exact same file that's being downloaded because I'm on a Windows server. If this was a Linux computer, it would say this file not found because I don't have a file with a lowercase m. So if I make this a lowercase m, refresh, now it's making me into a liar. I swear to God, I got it working just right before. Refresh. There it is. It was a caching issue. Now that I made the case m, now mod B only loads in once. Ta-da! So if you're any web address that you like, if you like, let's say if I load a file, and this is exactly what happened with me today. Fungi, right? I loaded a file called Fungi, in the path called Fungi, and then in another page, I loaded the exact same JavaScript file, but with a capital F. And not realizing I did that, and not realizing there is case sensitivity when it comes to module names or module path names, that this will actually load the file twice. And if, let's say, if you're doing some funky stuff in that module, certain things will break. It comes down to the point is, what are you doing in that file? You might not be doing if a module is completely self-independent and does not require any initialization, then you won't probably even notice it. It'll just be two copies of it in memory, and you wouldn't even be the wiser. But if you're doing some state sharing between modules, and let's say you, like I was doing today, and you load in one with a different case, not necessarily wrong, like they're valid addresses, they're correct addresses, but the browser doesn't know that because it thinks 99.9% of the web is case sensitive. So it automatically assumes that these two files are actually different files, not the same file. So if you ever have issues and it's weird that you're saying that your module is acting weird and you can't figure it out, the quickest way to check, go into network and see if that module file is being downloaded more than once. If it's being downloaded more than once, it's like, uh-oh. And it'll tell you exactly which page or which module file is loading it in. It should tell you. I guess not. What the hell? I swear, I thought I saw something that shows me which file downloads to which one. Oh well. But whatever, I digress. So yeah, just keep that in mind. If your modules are acting up, check network, see if it's being downloaded more than once. If you see it, you got an issue. All right, so now that that's pretty much all I can really say about modules now, and I can show you what I did with Fungi. And as you can see, Fungi is working as a module. It took a little bit of work, but it's back to work. And I did upgrades while, if I'm rebuilding the car, why not make the car a little bit better? So I'm using by default the grid that I created for the floor plan project I have that's doing on the side. I'm making it part of Fungi because I really like this grid. This grid is all the squares are 20% of a unit, so it takes like 1, 2, 3, 4, 5, another 5 across to make a single unit. So it's subdivided by like a quarter, 1/5 of a unit. So this cube is a single unit. It's like 1 unit across, like it's just a value of 1. So this is what the bare size of a cube, or a bare bones size in 3D space and WebGL is. This is like the standard unit, this cube size. So let's look at what's going on. I feel like I'm missing a file. I am missing a file. Where is it? This must be pointing to the wrong folder. It's the right folder, but it's I'm missing something. So I'm missing. It's pointing to this file, the project, because I haven't changed the project yet. But here's the HTML page. So I have a new HTML page. Let me just get rid of all these other files. We don't need them for now. So for Fungi, I got a new template page. Oh, and I probably also forgot to mention. Maybe I already did. I don't know. But let me just say it again. All modules have to have a script type equal module. That's another requirement to actually load up modules. I'm changing the code again. So you have to make sure it's that. There's something I think no module. So this is backwards compatible. So for some reason your browser does not support modules, the script no module will then run, and script type module will not run in older browsers. And in new browsers that support module, it will be the vice versa. The no script will be ignored, the no module will be ignored, and type module will be the one that runs. I don't care about using no module because I'm not worrying about if I'm prototyping, so I'm sticking with modules until everyone else catches up. As long as I'm not doing anything for production. Since it's all prototype work that I've been doing for like 9 months, and it's probably going to be doing for another year or 2. I'm pretty sure all the browsers, by the time I want to do this in production, all the browsers will be supportive. So here's a new template, and you'll probably see some cool new things. So this is how I'm importing. And now instead of having like all that JavaScript, you just have I think like 6 or 7 JavaScript files that I'm loading. In my starting page, I'm just loading what I need for this page. I just need the Fungi, and this Fungi used to be Fungi app. We'll take a quick look at it later. The downloader script we did 2 lessons ago, and face cube, where I used to have to load in primitives, and I would have to have like 5 or 6 different primitives that I'm loading up. And this, I like that I could just load up what I need. So when I load up one JavaScript file, I'm not loading every single primitive that I have developed so far. I'm only going to load up what I need. So that's one of the things I like about modules. You do on your own load. And I did one new upgrade to Downloader. I built a type shader. So now we can download shaders from the web server, from your hard drive, whatever, without actually loading them into the page. Because, when you start having like 3 or 4 shaders in here, it makes the page huge. It was driving me nuts. So now that the downloader works that I built for the GTLF video, I repurposed it and added a new handler for shaders. And I came up with a simple structure for shaders. And what I did is basically just these little HTML tags that I can very easily parse, and then just run a new function that kind of just takes all this information and creates a new shader and it's all the materials. So this is kind of like the create shader function, and this one's basically the new materials function. It just basically all the data is serialized. And then I can deserialize it and bring it back into the system. So I decided to save materials and shaders because materials are useless without the shader, and they're like purpose to the shader. So that's why I did it. And since I'm doing these little tags that I'm parsing any space in between is open game. So like if I'm like messing around and I make a material, but then I don't want that material anymore, I can just dump it in there and it'll never load up without actually deleting it. So it's kind of nice. I like this little format of creating shaders because it gives me room to play around a little bit. And if I need to do extra things, I'll just add in extra tags that can render out. And I can do, like I said, any space in between these tags or new tags that are not going to be loaded, they're just being ignored. So I can do, like up here, I put a description of what this shader is all about. So this now allows me from this moment forward to start building a shader library that we can then always reference back and reuse, because in the lessons I've always had to go back, copy and paste from a previous lesson from 5 lessons ago and make it inline again. This time we can now build, like I said, build a library moving forward in all our lessons. And I built one common shader that we've always been using a lot of is where we have the W component dictate the color. And so this way we pass in the colors as an array, and if we use, like say we set W to 0, it uses this color. If we set the W for that vertices to 1, it uses this color, and vice versa, and on and on and on. So I have like 2 materials. I have just the base material that has this color set, which I'm using for the cube, which is red, green, white, blue, and then shades of gray. And then I have the grid floor, which I have specific colors set up for the grid floor. So the grid floor and that cube, you share the exact same shader but different materials. Ta-da! So this whole thing is now streamlined. And the one thing I'm doing, I'm using, since these are promises, once all the promises are done, which is only one promise, I really don't have to do it this way. I can do .then and then automatically call it. But in case I create other processes that I want to run parallel, because when you create a promise, it's kind of like a thread in a way. So you can have like two threads running at the same time, and when all of them are done, then do something. And that's why I have this all set up. So basically, when this thread is done, then call on init. Else, if there's like an error, tell me what the error was about. So, I don't need to describe it because this is really we've done already. So, since I broke everything out, since I want the downloader to create the shaders, I need to at least initialize the GL context. So I have a fungi init and a fungi ready. So when everything's ready, then we finish setting up fungi, and then we start creating our scene, and then we start a render loop. And I made my render loop super small. Like I said, I kind of refactored certain things. I made things a little bit easier. Building a face cube is now silly simple than before. Before I had to create a VAO, then I had to create a renderable, thump it in there, and then put it in the scene. It was a pain in the ass. Face cube is now slimmed down, streamlined, so we can. And this is going to be the process moving forward. Everything's going to be modules. Everything will be more streamlined because we can kind of do that now, because the code base has gotten so complex, and then we need to kind of simplify things. And this whole module thing helps simplify things, and just going back and just kind of redoing certain bits and pieces. That's why I kind of been spending the last couple of nights rebuilding fungi. So this is really our new template that we're going to be using to starting all our lessons with. That was a shader. So this is what fungi looks like, and this is another use of actually what a good use we're about to say is another good use for modules is that you can take modules and group them together, like math. I like this module. If I load in maths, it would actually download all the math modules, and I have on top of that 2 constants that I can use. So if I load up this one module, I get all of this. So, and then I have every single module set up as named exports. So if I download, let's say, math, I can say I just want vec3, mat4, and quaternions, and that's it. And that's what that's the only references I'm going to get back. So even though I'm going to load everything, I'm just going to get those 3 parts. But I don't have to load in maths if I don't want to. If I just want, I just going to load in vec3 alone, and if that's what I'm only using, I just load in vec3 only and not download the entire math library. So that's another way you can use modules as a way to package up a bunch of mini modules. Like I said, all these are little mini modules. And remember, this all used to be part of fungi.core. It is a bunch, and they're very unchanged, in all honesty. If we go to vec3, it's a class file, and the class file is unchanged, and the only export is the class. I do a default export, and that's all it is. And that's what every single object for math is. It's very simple. So the fungi does the same thing. It just imports a bunch of other packages that I don't need to import into this page, because this page, it's like I only want is the fungi application, and that's what this one does. It gets the GL, it gets my camera, it gets my primitive, it gets my renderer, it gets my render loop, and it gets my camera controller. And as you can see, the camera controller has 2 classes, and I'm using named exports to grab them. And all of these other ones are basically just single default exports. And as you can see, like right here, I have a folder called cameras and orbits. I'm actually going to probably down the line create more cameras, and that's why I wanted to break things out and be more organized. But even though the JavaScript object is called orbit, I rename it to camera orbit. And this is pretty much what the fungi app.js file looked like a little bit, but now it's in a module format. It used to be a struct, and it's still a struct, but now it's the default. Like this whole struct is what returns to here. So fungi, so I can say fungi dot render, and I automatically have access to renderer, and renderer is still just a function, and it exists in utility. So and I kind of rewrote this a little bit. I moved all the global states into the renderer. Like I said, this used to be part at the very top of the core, but now it no longer is. Now it exists here because this is the only time it really makes makes sense. And like I said, it's mostly unchanged, except for certain references. Like the GL reference has changed a bit. Before it was just GL, now I have to say GL.ctx, which is short for context. But yeah, it's before I used to call it, I think was just like var r or var f, and now I'm calling it render. I'm just calling it the function. So I'm actually just, the main export is that render function. So that render function by default, and prepare next and process list, and everything else is private. You can't access this at all because I have no exports for them. So they're kind of like hidden away in a black box. And that's how render is. And probably the big piece of the pie is the GL. And like I said, GL still has its init where it kind of sets everything up. Fungi app used to do this. Now GL does this. Now it creates the UB transform here, because we're going to use that for everywhere. So it's an important part of Fungi, and it's how all the shaders are going to be using the UBO for transform. You have the clear function, and in the previous version of like we had is I would take the GL context or the GL function, like this part, get element, create canvas, and I would get the context, and that would be GL, and then I would actually start adding functions to it. Clear used to be called fclear, and that was something I would append to this. I'm not doing that anymore. Since I'm using modules, context is now separated, like context functions are now separate from my custom functions. Before, I had my custom functions commingling with the functions that exist with GL context. So that's why, like, the context has a function called clear, but I wanted my own clear function, so I had to call it fclear. So and all my custom functions were called clear, and that's kind of sloppy, hacked kind of approach. But without modules, it was kind of the best way to go about it for me. So by setting up modules, I can kind of do things a little bit clearer and clean. So now this GL module exports a struct. This page is still kind of big, but I'll show you what it exports. It still exports a struct. I have in it my context. That's everything that's being loaded up. Width and height. I can access the width and height now directly. I always could. And then all the functions that we're used to, create array buffer, create UBO, fit size, set color. This used to be a part of utility class. Now I brought it part of this GL because it's anything that's related to GL functionality and data goes into the GL module now. This includes this. This used to be part of the shader utility class. Since this is all GL related functionality, it belongs into GL. So like I said, that's what I did. And we have it now, and GL module is also handling all the resources that's related to GL. And so that's the main default export, the mod. And then I have a couple of named exports. I have some constants I want to export if I need to access them and sort of things. And I have our VAO, UBO, and FBO classes, and they're unchanged really. Like I said, they've only been updated to access the correct variable for the GL context. But other than that, these are pretty much unchanged from all the previous lessons that we went and actually built these and learned how all this functionality works. So these classes now exist in this module, and I can load them in whenever I want, and I do. Like the renderer, like I load in GL, and I just want the whole thing. Well, actually, I want the whole thing. I want all my default stuff, and I want one named instance. I just want that constant. So I'm instead of bringing all those other constants and without bringing VEO, and all that stuff into this module, I just want the GL stuff and that constant. So it's more organized of what you're getting. And that's really, the only thing I can really show you now is entities. And entities is where renderables and transform exist. And they're relatively unchanged. Renderable is pretty much the same. Very little has changed. Like I said, instead of GL.triangle, I have to say GL.context.triangle. Those are the only little small changes that had to be done. But overall, everything's fine. I import transform, and then I can extend transform from renderable. And transform is and here's an example of I'm loading in the entire math library, but I only want those 4 pieces from the math library. I can do I can do 3 different imports, vec3, vec4, and quad, but Fungi is going to need all the math objects at one point or another. So I just grouped them all in the math.js, and when math.js gets called, it downloads all the other ones. And that's how Fungi now is built. It's built like this, and everything is broken out. Like just about every object is its own module, except for certain things like the GL one. That's like a really big package of functionality. But that's fine because they belong here. That's the whole point of modules. If you have a bunch of functionality that's kind of grouped together, that's just put them in one module, and that's what you share, and that's what you can import. There's no really, like I said, there's not much else to show you. Like a lot of stuff is kind of just small tweaks here and there. I guess I can show you the downloader. It's built a little differently, but it's still the same. Instead of having a class, I built everything as global functions and stuff in at the global scope of this module. So it's no longer a class anymore. So it's just a collection of functions and variables. That's what pretty much a class is anyway. But since I don't need to have this run as a class, let me just build this in a slightly different way. And this is the new function that downloads shaders and renders it. It's very simple. It's just very simple JavaScript. Why won't it let go? All right. And yeah, it's just very simple stuff. And it's commented. I write a lot of comments. So if you guys want to go through it and want to understand how some of these things work, the comments will help you. Another thing I love about having modules is that I can actually do things like this. I can put documentation of the module inside the module, where when I had everything in one big JS file, it was very difficult to put documentation in there. Now that everything's broken out, I can put some documentation. I can put sample code, and it overall it just makes it like a better way to really manage and maintain a large library of functionality. So like I said, if you're really into building libraries and stuff, and you're doing a lot of JavaScript, this is really how it's going to be once everyone catches up. So right now, with the Chrome, you can start using it now out of the box. If you want to start prototyping, start playing with it, and start seeing how it works. Now, the last thing I probably want to say about modules is that there's only one thing I don't like about modules. If I go to Developer Tools, if I go to Network, I have to refresh. This is the only problem with modules, especially if you break them out. If you have a library and you break everything out into small little pieces, you have boatloads of JavaScript files that gets downloaded. If the browser is smart and the server does not mark a no cache on a file, the idea is that the browser will download this file and store it into your browser cache, and then if the next page that you load up, it'll just use whatever in the cache, so it doesn't have to actually download anything. And I remember before I was saying, this thing will tell you which loader what. Now this finally tells you. I don't know why over here it doesn't. If I go to Network, how did I get that list again? What button do I press to get that list? I forget. Well, whatever. It wasn't giving me that list before, but now here's I knew it did it. So if you saw the same JavaScript being loaded twice, the initiator will tell you the two files that are importing them, and then you can probably determine which one has a case that's different. So this is, like I said, it should tell you, and here's finally I'm vindicated. Chrome does tell you what's imported from what. So yeah, I guess the type is script, and it's being downloaded. So Fungi downloads a lot. Math downloads a lot. So that's, like I said, this is really the only thing I don't like about modules, because now you're downloading boatloads of files, and that can take, depending on the speed of your connection, might take a while for a page to load. And if you're using mobile phones, this might be an issue with mobile phones and mobile data. Mobile data can be a little slow, and you have to download all these files to have them render. It's not terribly efficient. So this is the only issue I see with modules. So I just want to point that out. It's that's a con. It'd be nice if there's a way to kind of still have the modularity of it, but make it one big download. So it'd be nice if you could do that, but not so much. And that is modules. That is ES6 module support that is now officially part of Chrome version 61. I'm almost done getting floor plan and raycasting working as modules, and once I get that working, I'm going to continue writing up some code and prototyping ray casting. I've been watching so many videos and reading so much documentation on ray casting, and I'm actually trying to understand the math about it. There's some like nice videos that teach you the actual math. Like here's the cross apply, here's the two forms of cross apply, blah blah blah. This is here's the point, here's the line, you connect it, you make a triangle, then you use these equations. I'm going pretty deep into this so I want to understand it. So when I explain it, I can probably have like a good idea of some of the mathematics, not like 100%. I'm not going to understand it 100%, but at least I know what's going on and understand some of the math. So when I explain it, hopefully you guys will get it. I can come up with maybe a nice way to explain it. But there's like one video I probably watched 5 times, and it finally clicked in my head how line and plane intersects. So in my head, I can visualize and understand how line plane intersection works. So I'm definitely going to work on that, write some code to implement that, and visually see the intersections, and maybe draw extra lines to build a triangle, and so this way you can kind of see the mathematics at work a little bit. So that's the plan for ray intersection. So I'm kind of hoping to do first. I want to definitely do ray plane, and depending on how big that is, I'll just make a video on just that to begin with. Or if it's not that big a deal, I want to try to do go from plane to rectangle. So this, if I have a quad, I just want to point it at a quad, not an entire axis plane. And then I want to do cubes, spheres, and if possible, capsules, because capsules is also another fundamental shape for collision. So I will love to have all those squares, cubes, spheres, and capsules, and of course planes. With those 5 things, you can do quite a lot of collision detection at that point, at least with rays. Circle to circle, or sphere to sphere, or sphere to capsule. That's all other stuff that I haven't even gone to that point yet. But line interceptions into those 5 pieces is really the next couple things I want to do. Then I'm going to go back to skeletons, which I have to then kind of put together as a module so it can actually work correctly with fungi. So that's what we're going to do. So that's what I'm working towards. So I'm going to raycast. I'm definitely going to do raycasting. Like I said, I'm already understanding line to the plane intersections. I totally understand it. I can visually see the triangles and whatnot in my head, and I understand some of the mathematics that goes behind it. I still haven't gone to spheres and all the other shapes yet. But like I said, depends on the complexity of it. I just might do just planes, and then maybe break everything out into individual videos. Like for out of every single type that a line can intercept, I'll make a video for each one. Or I might just do line to plane intersection, and then do the remaining 4 or the remaining 3 as one video, because the plane intersection is the first step of everything else. So like spheres and cubes and whatever, you have to do a plane intersection first to start with, and then you kind of branch out to more things. So I guess plane is the most important thing to learn first, since it's the beginning understanding of intersection. At some point, maybe I want to do line to terrain intersection, because that's different too. I will learn how to do that, so this way we can have terrains, and then we can intersect and maybe move things around terrain and stuff, or like maybe even draw a terrain, like point at a certain spot of a terrain, and maybe I have like a brush shape, and any vertices in that shape can rise. So this way we can kind of do like terrain modification. So once we can do that, we can do intersections, and we can find what vertice of that terrain, we can then start morphing the terrain with the mouse. So that's another thing we're definitely going to do down the line once we learn a lot of this functionality. So yeah, that's it. We're finally done. This is probably a real long video. I thought this was gonna be like maybe a 20-minute video, but I'm talking a lot about you know what modules were and how fungi is not being rebuilt, and now telling you with the next video. I probably shouldn't waste too much time talking about the next video, but I know someone's waiting for that intersection, so I probably want to tell them it's coming. If it wasn't for Chrome updating to 61 last Friday, this week's video would have been about intersections. So you can blame Google and the Chrome team for releasing the feature I've been waiting months for. It's their fault, not me. I'm a creature of habit. Any new toy, I'm going to jump right on it. A bleeding edge. Like, I started this tutorial before WebGL 2.0 was officially released. I remember the first couple of videos we had to enable WebGL 2.0. And then I think a few weeks later, then I think version 60 came out, or 59, and WebGL 2.0 was I think available out of the box without, I think, any changes. I believe so. I think you don't need. I don't think you need it. I think it's out of the box, open. It's official. So yeah, we're always about the cutting edge. The moment some technology comes out, jump right in. Another thing I saw just recently is like hand tracking with JavaScript, and I actually have that little device. The Leap Motion. I have. Is it Leap? Yeah, that thing's called Leap Motion. Like, in my head, I'm thinking Leapfrog or Leap Motion, but I have a Leap Motion device that was given to me like a couple years ago. I never really got to play with it because I couldn't. I was never. I always thought I was too stupid to be a graphics programmer, and in the last 9 months, I proved that I probably am smart enough to be at least a junior graphics programmer. So you can actually do hand tracking in JavaScript on a web page, just by downloading I think a plugin or something. I'm not sure, but I saw an example of it. I was like, oh, that's awesome. Now that we have skeletons functionality in Fungi, I can actually have Fungi interact with Leap Motion, and then and just have that hand being controlled on a web page. That's definitely something we're gonna do. I just don't know when. It just really comes down to a point when I really need to do it. I think maybe once the skeleton functionality is in a really good place where I can do animations. I think by the time I can animate skeletons just right, maybe I'll jump onto that. And I don't know if you probably a lot of you don't even have a Leap Motion to begin with, so probably it's kind of pointless. But if anyone that has a Leap Motion and you want to learn how to interact it with the web page, there are tutorials out there. They do have it. I suggest if you want to jump on it, go for it, and just use 3.js as your backbone to animate. But whatever. So that's it. I probably wasted too much time babbling on about other things. I can sit here for hours and talk about technology. So I gotta let you guys go. Hope you enjoyed it. I'm sorry to anyone who's upset if I completely rewrote Fungi on top. Even like I said, most of the code is unchanged. Some has changed for the better, but for the most part, it's what we've built in the last 9 months together. But I'm sorry if I kind of just changed the whole paradigm of how Fungi works within a single day for you guys. So if you're upset, I'm sorry, but it's for the best. It makes it so much easier to manage the code. I think once you start playing with modules, you probably tell yourself, why hasn't they done this sooner? It's like, why did they drag their asses to add this functionality to JavaScript? It's been existing since Java, and Java is a little bit older than JavaScript. So yeah, that's it. I'm gonna leave you guys alone. Thanks for watching. Like and subscribe. See you guys at the next lesson.